Hello to everybody. Today's video is about to make your own neural network using MS Excel just in 30 minutes. My name is Alexey Teslenko. I'm CEO of big company and my big passion is to make complicated things easy enough to make other people become able to understand them. Is it possible that artificial intelligence ever replace a human? Definitely yes. Many professions will disappear soon. This new society will encourage those of us who won't be afraid but will know how to use it instead. I'm not a specialist in this area as well as you probably, but you will see that nobody needs to be a specialist to be at least familiar with the basic things. Watching this video, you will know enough to make a really working neural network and then to step over more difficult tasks where AI can be used.
Let's just first put a problem. You are a manager of retailer, and you have 4 different promotion items which goes as a gift along with any purchase with total amount more than $100. First is compact automatic umbrella. Second, porcelain cup. Third, smart sport bracelet. And fourth, stylish headphones. You are thinking about to offer just one of them to your website visitors when they sign on. You know some information about your website visitors, gender, age, and income level. The most apparent way to solve it is to make a clear decision tree what should be offered for each combination of known characteristics. Another way, and this is what we're interested in, is to let neural network to learn the best choice from an experience. Is this a really good idea? Yes. You cannot be sure what choice is the best for mature lady or for a student. Well, we have an interesting problem, and the only thing we need to solve it is Microsoft Excel. It is always better to split a complicated task to small pieces. There we have 4. First is to make a random input with a combination of age, gender, and income. Second is to give birth to a baby neural network. I call it baby because at the beginning it will have no experience, but it will get input data, process it, and give an advice what gift to offer. Third is to make interface to evaluate each advice. And at last, we need somehow to make a baby to learn more about client's preferences. This part is the real magic. I like it most of all. So let's start from the very beginning. You know that Excel can use random values in calculations, so using it we can get a random combination of characteristics. Let us state all the options right here for gender, age, and income. Next, we can use function randBetween for getting an integer value within given interval. Here we need 2 values, 1 or 2. In next cell, we will make an interpretation of the value using function choose. Do the same with other parameters. Well, to have a new combination of values, you simply need to push F9. Then we need to translate the values in binary signals, like yes or no. Using if, we will get needed values. Let's test it. From biology, you probably remember that a neuron has a few small legs, dendrites, which receive signals. These signals are electrical and can be measured. So, to finish with step 1, we need to denominate yes and no to numeric values that will reflect an amperage of the particular signal. Yes will have strong signal with value 0.99, no otherwise a weak signal 0.01. On step 2, we will start making a real neural network. You will see how easy it is. Our neural network will consist of 3 layers, so-called input layer, output layer, and one hidden layer. For us, a layer means a matrix with random values, which we will call weights. An input layer should have a size equal to number of input signals. Let us just mark the matrix with yellow color. Hidden layer will be the same. An output layer will have one side like we had before, and another is equal to number of possible options, 4 in this case. Cell marked by yellow, we need now to put some random initial value from minus 0.99 to plus 0.99, but not 0. This can be gotten by such a complicated formula. We will not waste time to clarify why it is so, just do the same. Now I will copy it for every yellow cell and finally copy all as values, just they not to change every time. Alright, just hold your breath. You are looking to a brain of your baby neural network. Let's teach it to think a bit. Each layer must transform input to some output. It doesn't simply get its sum of product of each column with input row. In math, it calls matrix algebra, and fortunately Excel can do it by exquisite and simple way. There are 2 hints about matrix formula you must know. First, you state it in one cell, and be careful, don't forget to fix all references in formula. Then you copy it to all cells where you need to get a matrix result. At last, and it is very important, you need to select all the range, press F2 to start editing, and press Ctrl plus Shift plus Enter. If you do it correct, all the formulas should appear in that kind of curly braces. We will get the result of thinking of input layer here, and you can see a variety of values here. What we also need is to normalize them. We don't need too high and as well too low values. There is a magic formula which calls sigmoid that fit to this purpose the best. We don't have time to dive deeper in details, so please just copy the formula. Okay, What we have done. From variety of outputs, we got set of values from 0 to 1. Whatever value you push to sigmoid, it will always give something between 0 and 1, but the output will never equal to these numbers. Values close to 0 will be processed to some around 0.5. Big positive values will very close to 1, and big negative will very close to 0. That is, by the way, a reason why we use 0.99, not 1, to represent yes, and 0.01, not 0, to represent no. Well, what this output actually is? Yes, it is input for hidden layer. Let's do matrix algebra again and get input for the last layer by the same way. It remains to get result from the output layer with 4 values, again normalized by sigmoid. We finally got 4 values as an output, and it's time to interpret them to a choice of the promotion gift. The choice can be just a single, so in this cell we will define a position of maximum value and a name of particular gift that is recommended. Let's see what we have here. Oh, our baby now can think. If you are afraid of World Robot Revolution, I recommend to stop right here. Okay, let us now evaluate the advices the neural network gives. Every time you push F9, you get a new combination of input and a new advice. These advices at the beginning are not so smart. But look, what you expected from a child that just has born. You made it alive, so you are responsible for teaching it. I prepared this simple option list in advance to be able to give a child a correct answer. It can be your judgment, or following to our example, it might be a result of choice of your clients. In any case, to make neural network able to learn, you need to input enough of correct answers. So this option list, just simplify our example. Copy it as it's shown. If you disagree with my choice, you can state any other. This mature woman with normal income was offered by Umbrella as a gift. I will state a complex formula here to select the correct answer from that option list below. We are lucky that this time our neural network was right. It recommended Umbrella, and the correct answer is Umbrella 2. But when I press F9, other combinations come, and now the advices are wrong. Actually, it recommended Umbrella each time. Now we need to let the neural network to know what option is correct. For that, we will calculate 4 values with 0.01 for all wrong options and 0.99 for correct option. The differences between values we got as an output from neural network and correct values are partial errors. Sum of their squares is a total error. If to imagine that output is equal to correct answer, the total error will be zero. If it is close to correct value, then the total error is low. We will say that the network is well taught when the total error for every trial will strive for zero. Well, we got a last step, a learning process. From each trial we need to find out how to improve the quality of the advices, or in other words, to give output closer to the correct answer. Next to this column of values, we will calculate a change of all the weights, which will make a network give a little bit better output than it was before a trial. A little is a key word in this phrase. A learning process should be gentle. This time we need to go from end. The formula is not as simple, so be careful and double check that you did everything correct. So first we take errors and process it through normalized output from the last layer. Here we should find a product of these values and normalize output from previous layer. Because of the rules of matrix multiplying, we need to turn around this row into column using function transpose. Pay attention that this function is also matrix, and so it needs Ctrl plus Shift plus Enter to be done for all the range. Having it, we multiply it to this row and got a big matrix of values. Next we do the same with one layer back, but first we need to have partial errors as input for the formula. We can get it from multiplying errors we have on transposed matrix of current weights of output layer. Having it, we do the same and get matrix for the hidden layer. Again, we have partial errors for input layer and do matrix algebra on this final step. So we are hard workers, and we have just finished all the difficult part. Next we will just enjoy. This was a real magic. Just consider that scientists went to this formula by decades. All the values we have just gotten are changes of current weights represented here in the tables marked by yellow. It means that if we change all the weights by these values, the baby will become a bit smarter. We can regulate the speed of how fast the neural network will learn. This calls a learning ratio. We will put it here with 0.25. It means that for each trial we will change just for a quarter. Well, in next column, let's calculate a new values of weights. Now I want to freeze the moment for a while. Every time we have a random input here. So I will copy these formulas above and then leave given values here. Now when I do a calculation or press F9, nothing changes, but this small area on the top. I needed to show that in each step the total error decreases. So now we have 1.02, then I copy new values and voila, got a 0.95 instead. At this point we need to record a macro, just not to do all the following routine every time. Let's return back the random input formulas. Then we need to show a special menu which is hidden by default. It calls developer. You can find it here. Start recording macro and then just copy new values and stop recording. Let's add a button for this macro. Now all you need to teach your network is to run the macro many times. Pushing the button will make the network smarter and smarter every time. The problem with all neural networks is that to teach it well, you need hundreds and thousands of trials. If you did it, you would get needed result, but it would take too much time. So now we will add a bit of automating in learning process. This is our small macro we have just recorded. We can delete everything before this row with selection of range with new values of weights. We can also delete all scroll commands Excel recorded because they just make the macro slower. I want to repeat this copy action 100 times and use operator for to this purpose. Then you need to move all the code inside. And one additional thing, Excel must recalculate new values every time and we need to instruct it. Let's try to press the button. First time, it looks like it freezes, but just wait. 100 trials and take some time. Next time you press the button, you see all the actions. So process of learning become much more effective. We know that each time we press the button, the neural network becomes smarter. But it would be nice to measure it somehow. What I will do is to set up a counter to record a number of correct answers. It will take a bit of code. When the network gives a correct value, these two cells are equal, so we will add a simple if, which return 1 when they are equal and 0 when no. Then we change our macro a bit. When we now run the macro, in this second cell we will get a number of correct advices our network gave from 100 trials. Oh my god, it's amazing! We are going better and better. I will make the video runs quick, not to make you bored. Wow, now we finally have 100% of the correct answers. Our goal is achieved. Surely, this was just a demonstration. A real neural network is more complicated and demands bigger resources than Excel theoretically can provide. But this small network did a good job for us. And the most important thing you need to understand is that we did not set any algorithm for doing it. This little magic construction with just 20 artificial neurons learned by itself which gift is better.
You know what I think? It was impressive. Can it be useful for you? I don't know, you will decide. My goal was just to show you in 30 minutes that AE is not something too complicated, expensive, or unachievable. I hope this was interesting. That was Alex Teslenko. Follow my channel in YouTube to be aware when new business life hack comes. Bye bye and make your job inspiring.